Hello and welcome back to the channel. In this video we'll be going over estimations. So the first thing we're going to look at is carrying out simple operations and estimating those operations. So when working with estimations in general, you have to think about how you can round each number you have to one significant figure. So in this case here, 45.6 would become 50. Because the 5 would make the 45.6 round up to 50, and then the 37.3 would round up to 40, and you just have 10. In this case we'd have 60, not 55. You might be tempted to turn it into 55 because it's so close to 55, but actually no, it would be 50. We'd round it down because the 4 would make the 54.9 round down to 50, and then 2.4 would round down to 2 to one significant figure, and we'd be left with 100 here. And then the next one, we'd do the exact same. So 649 would round down to 600, 38.9 would round up to 40, and then 0.416 would round down to 0.4, and that is to one significant figure. You have to remember that with decimals, it's one significant figure is not the 0, it's the first number that is not in 0 after the decimal point. So in this case we'd be left with 640 over 0.4, and that is 6,400 divided by 4, which gives us 1,600 as a final estimate. Alright. The next thing we'll look at is estimating roots, that is square roots, cubic roots, and any other roots you can think of. So when estimating roots, we have to think about the number that has a known root that is closest to the number that we're given. So in this case 77 is closer to 81 than it is to any other number that is a perfect square. So square root of 81, so our estimate here would be 9. In this case we have a cubic root of 29. The closest number to 29 would be 27. That is a perfect cube, and that would give us 3. In this part here we'd do the exact same thing that we were doing earlier for the inside part of the root. So we'd still have the root 4 outside, but we'd have 20 minus 5, which would give us 4th root of 15, and the closest number that we have that has a perfect 4th root is 16 to 15, so we'll take the 4th root of 16 here, which would give us 2 as our final estimate. Alright, the next thing we'll look at is area questions involving estimates. Now these questions tend to come up quite a lot. They do like to add and mix area questions into your exam papers, especially the higher ones at the beginning of your paper, because the rest of it can tend to be quite easy for higher. So do pay attention to this part of the video. So in this case, if we want to estimate the area, it would be half base times height, because that's the formula for the area of a triangle. And so we'd be left with half times by the estimate of the base would be 50, again rounded to one significant figure, and the estimate of 18.6 would be 20. This would give us 10 times 50, which is simply 500 meters squared. Here. Have a go at working out the area of this trapezium at the bottom. Pause the video and I'll be with you shortly. Alright, so the area of a trapezium is A plus B over 2 times y perpendicular height, where A is the first base, B is the second base, and the height is the perpendicular height. So in this case this would be 41 plus 7 plus 64.9 over 2 multiplied by 102. Now we're estimating this area, so we'll round everything to one significant figure. So in this case this would be 40 plus 60 over 2, and that is all being multiplied by 100. And what we get is 100 over 2 times by 100, giving us 50 times 100, or 5,000 centimeters squared. And that is our final estimate. Okay, have a go at this question here, which asks you to work out the radius of the circle and gives you the area. It gives you the area and asks you to work out an estimate for the value of x. Right. Okay, so the area of a circle is pi r squared. Right. We can rearrange this formula to give us the radius, so r squared is equal to the area divided by pi, and r is equal to the square root of the area over pi. Okay, now we can start plugging in some values into the formula. So square root of the area, which is 337.8 over pi, and our estimate would be, to one significant figure again, 300, and then pi we know is equal to 3.1415 whatever, so we'd round that to one significant figure to give us 3, and so we'd be left with the radius being equal to the square root of 100, which is 300 divided by 3, which just gives us 10. So our final answer is that x is equal to 10 centimeters. Alright, that's the end of the video. If you found the video helpful, please do like and subscribe, and I will see you in the next one.